Hello guys, once again this is teacher Nicoy and we're here in basic calculus week 6 day 2. So today you will be able to use the extreme value theorem in solving optimization problems. Okay, optimization using calculus. Okay, such problem is classified as optimization problem is what we call best value. Huh? Okay, so maximize or minimize here we have here, and then okay, so you have the module, you can read about this, and then we go directly to the example. Okay, so we have here a rectangular box is to be made from a piece of cardboard 24 centimeter long. So this is 24 centimeter here and 9 centimeter wide, so this is 9 centimeter. Okay, so 9 centimeter and wide. By cutting out identical squares from the four corner, as you can see here, uh, identical squares are being cut in the four corners, and turning up the sides, find the volume. So what he gonna do here is I'm gonna what you call that, raise this one, also this one right there to form a small box. Okay, so in drawing in drawing, let's say that is straight. Okay, in drawing that's supposedly what will happen. Okay, so after cutting this one, I'm gonna this will be the sides, yeah, sides, and this is the supposedly that there is a width there, that's the width, I mean width, and this will be the length. Okay, so okay. As you can see in the drawing, let's simplify the drawing. It's not nice to see. Okay, so okay, let's draw it here. Hope this thing works. Let's draw that one. Okay, let's draw a box. Have identical. Okay, then okay. Okay, supposedly we have width that is 9 centimeter, right? Centimeter, but we have cut the I mean the sides, and the sides to be here. This one is already the sides. This one, that's already the sides, and our length also is 24 centimeter, and then we cut the sides, so this becomes the side right here. Okay, so what we have here is in order to have the volume, because we all know volume is length times width times height, right? So our length here is not 24 centimeter, but it is 24 minus, because we have cut the sides. We have cut how many sides we cut? Two, right? Two sides. So 24 minus two sides, right? And then the width will be what? 9, right? But we have cut two sides also, right? Here, this is the two sides. Let's put the width as the blue one. Oh, 9. Okay, so this one is also a side here, right? So we have cut two sides, so 2s also times the height. What is the height? Of course, it is the side. Okay, so we have here the volume. Okay, so what we're gonna do is we multiply this one. We simplified it until it is very easy to derive. Okay, so we have here, first we're gonna use the FOIL method, 24 like that. So oh wait, wait. Okay, so we're gonna put it here. So 24 times 2s plus 9 times 24, and then we're gonna have this blue one. Whoa, why blue one here? So we have here minus 2s times 9, and negative 2 times negative, it will be plus okay, 2s times 2s, and this one will be multiplied by s. Okay, so we have here, okay, so 48s plus 9 times 24. We're gonna use our calculator. 9 times 24 is 216. 6 minus 18s plus 4s square times s. We're not done yet. We have still s here. Okay, then like terms, 48. So we have here 48 and 48s. So this will become 216, and then 48 minus 18 is 30. So plus 30s, and then plus 4s square times s. So we're not done yet. We have still s here. So we have, we're gonna rearrange it to make this one the bigger one. So first we have here, so 4s cube plus this one here, 30s square, and then this one here, which is 216s. So we're gonna check it here. Whoa, why it is 42? Okay, we have something wrong here. Supposedly 42s. 24. We're gonna recheck what have gone wrong. 48s. Oh, here we have it wrong here. So supposedly, you can see we multiplied 24 and negative 2, but we put positive. So this supposedly a negative 1. So that's our mistake. But why is it 42s? So supposedly it should be much bigger than that. What is wrong with this one? 48. That should be 52, right? Because here we have here 48. Where's the value? So negative 48 minus 18 is negative 66. So that's supposedly negative 66. Wait. Okay, so we're back again. Okay, so that is our mistake. Instead of, okay, so it is negative 66 here. So we erase this one and change it to negative 66. And then this one into negative 66. As we can see here, it is negative 42s square. It's kinda how did the author get this negative 42s square? Okay, so what will happen to this is this will become wrong, right? Wait. Let's see here. Why did she have for 33s? Oh, she already 132. How did he get 132? Okay, so we're gonna analyze this example. So supposedly, he has 42. So 42 times 42 times 2 is 84. But here, he 132. So 66 times 2. Okay, so maybe it's just uh, an error. This is an error here. Supposedly she should, or he or she should write 66 here. Okay, so also let's remember this is just a module. It also has what we call that, mistakes. Just like me here, I also made a mistake. We have not put the negative sign, and that makes us pay in the down here, right? Okay, so now we have this function over here. Okay, so let's proceed. Let's move on. Okay, so what we're gonna do, we do the let's back again. We do this step 1. So what is step 1? We copy the function 4s cubed minus 66s squared plus 216s, and then we derive the function. So once again we separate, and then we bring it down, and then we subtract 1 square. So the same here, 66 times 2s plus 216. Okay, so here we have here, wait. Okay, so 4 times 3 is 12s square minus 60 132s plus 216. Okay, so we're gonna try to get first the 12. If we can get the 12, okay, so 132 divided by 12, 11. Okay, it is divisible by 12. How about 216 divided by 12? 18. Okay, so we can get the 12 here. So it will be s squared minus, what is 132? 132 divided by 12. It is 11 plus 216 divided by 12, which is 18. Okay, so this will become more manageable to factor out. Okay, so we have here 18. So what is 18? Or 11? How to get this 18? So we have to multiply two things. So like 9 times 2 equals to 18. What is 18 times 1? Yeah, equals to 18. How about 6 times 3? Yeah, 6, 12, and 18. Yes. What are the other things numbers we can multiply? Two numbers we can multiply to have 18. I guess we have this one, or this two only. So it is positive, so it could be positive times positive or negative times negative. Because if we have positive times negative, this will be negative. This sign will be negative. So positive and negative is not desirable. Okay, so now we have to get this negative 11. So how to get this negative 11? We need to add or subtract. Wait, okay. Home credit is calling. Okay, so positive and positive in order to get negative 11. So we have here 18 minus 18, and no. This is positive 11. If positive plus positive, this is positive 9. So we erase this. So this is impossible to work for. So we have here negative and negative. So negative 9 plus negative 2 is negative 11. So correct. Negative 11, 18 plus negative 1 is no. It is negative 19. How about this? Negative 6 plus negative 3 is negative 9. So wrong. So this will be our answer, which is negative 9 plus negative 2 is equals to negative 11. So that's it, right? Okay, so we have here 12 times s minus, 11, s minus 9, and s minus 2. Right, so if we times here, okay, so this will be positive 18 and this will be negative 11. Okay, correct. And then we have this two value. Sorry, what happened? Control Z. I'm controlling Z. Okay, so we forgot to equate it to 0. So this equation is equated to 0. So x equals to 0, then s minus 2 is equals to 0, then s is equals to 9, and s equals to 2. How about 12? So 0 is equals to 12, so 0 is equals to 0. So the constant number will be divided to 0, which will make him to become 0 also. Okay, so we're not including that one, so let's proceed. Before we proceed to step 2, okay, so we'll go back to the design here. Okay, what if he folded? What is the maximum value of this side? Okay, what is the maximum value of the side? Here, this one, what is the maximum value of this? Of course, the maximum value of that will be, example, we have this length here, 9. We can only fold half of it, right? We can fold half. So 4.5 here and 4.5 there. Because we know that the side is equal, right? Cutting identical squares, so square this, the side should be equal. Okay, so if we cut 5, and then here 4, this is 5 and this is 4, so the resulting would be like that, right? If you fold it, it is not identical anymore. So what we're gonna do is we need to set a limit, right? We need to limit the biggest side. Okay, so we have here 24 also. So the biggest side should be, if we have this, it's 12 and 12, and this is 4.5 and 4.5. Okay, so what should be our biggest side? What should be the biggest value of the side? So the biggest value should be 4.5. Why 4.5? Because if we use 12, this side is not efficient or sufficient enough. It is insufficient. So that is why we're gonna use 4.5. If we use 5, it will be more than the half of this, of the width. So our side will not be identical. So we're gonna use 4.5. Okay, so our value, our interval should be, here we have this one, right? This one should be 0 to 4.5. 4.5. Okay, all right. Okay, so we proceed here. Now let's copy once again our what you call that, our let's copy our function, which is vs is equals to, let's go back, 4s cube. Okay, we'll go back here, 4s cube, minus 66 s square plus 216, was that 216s? Okay, 216s with the interval of 0 to 4.5. Okay, and then we proceed to step 2. We proceeding to step 2, we copy that one. Okay, this is not f of x anymore. It will be, wait, what are you doing there? It will be vs, or this one is not x anymore. It will be s. Okay, so our value should be 0, and here is 4.5. And then what is the other value here? So let's go back to our step 1. We have wait. We have 9 and 2. So we remember our interval is up to 4.5 only, so we use the this one only, s equals to 2. So we have here 2. All right. Now we're gonna put that one over there. We're gonna evaluate it. 0 square plus 2160 is equals to 0 cube is 0 times 4, 0 minus 0 square times 66, 0, 0 plus 0, so this is 0. Okay, and then we have v2, which is 42 cube minus 66 2 square plus 216 times 2. Alright, so our volume with 2 will be 4 times 2 times 2. 4 times 2 is 8, so 8 minus 66 times 4 plus 216 times 2. What is 216 times 2? It's okay to use our calculator. 216 times 2 to make sure of the answer. 432. No need to use a very high-end calculator. Just this one is fine, right? 32 minus 66 times 4 is 264 plus 432. All right. Okay, so 32 minus 264 plus 432 is equals to 200. That is the the volume. So okay, how about we use 4.5? V 4.5 is equals to 4 times 4.5 cube minus 66 times 4.5 square plus what you call here 216 216 times 4.5, which is equals to, okay, we have here 4.5 square. Okay, we'll not use that one, so we'll use 4.5 times 4.5 equals to 20.25 times 4, which is equals to 81 minus 4. Wait. We have gotten this wrong. Why? Because we only multiply 4.5 twice. 4.5. We should multiply it 3 times 4.5 because it is cube. 91.195 times 4, which is 364.5. Okay, 364.5 minus 4.5 times 4.5 is equals to times 66 is equals to 1336.5 plus, okay, 216 times 4.5, which is 972. And then we add that all, 364.5 minus 1336.5 plus 972 is equals to 0. Okay, so we have here 0. With this is 0, this is 200, and this is 0. Okay, so we can also see, we're gonna try to graph that one. Wait, this is our grapher here. Okay, 4s cube minus 66s square plus 216s. Gonna try to graph that one. Wait, what happened? What is it? 4x. I forgot. We need to use x. 4x square. You should have graphed that already. Then minus 66x square. So this should be supposedly cube. What happened? What happened, GeoGebra? So let's reload this one. I think it's lagging. So 4x to the power of 3, and then minus 66x square, and then plus 216x. No. And then plus 216x. Okay, so this is the value here. What is this looking? Okay, as you can see here, you can see it reaches 200, right there. What is this value? 2 and 200. Okay, so below it should be here also. This one is 9 and negative 486. These are the critical values of this graph or of this function. Okay, so remember what is our in here? We have s equals to 9, right? So the other critical value is 9, right? X is 9. Okay, so let's go back here. Now we can say that what did he need, or what did she need? Find the volume of the largest rectangle box that can be formed. So the largest rectangle box, I mean the value of a side. No, the side should be the volume, the maximum volume is I mean S, that should be S. Volume should be 200 when X is equals to when S is equals to 2. So that will be our final answer. So let's check if we have it here also. Yes, we have the same answer here. Okay, so now we proceed to example number 2. Okay, in this example number 2, we have here find the number. Wait. What happened? Find the number in the interval negative 2 to 2 so that the difference of the number from its square is maximized. Okay, so if you have x is equals to a number, then you say the difference of the number from its squared is maximized. So we have here x squared minus x, and then we maximize it. So mx equals to x squared minus x. So we're gonna have the step 1. What is the step 1? Which is copy the function x squared minus x, still the same, and then we derive the function. Okay, let's zoom in a little bit so it's easier to write. So deriving it will be 2x minus 1, and then we equate it to 0, And then we have here 2x equals to 1, and then divided by 2. Wait. Divided by 2 over 2, and then we have here x equals to 1/2. Okay, so we have x equals to 1/2, and then we do the what is the interval again? Here we have the interval of -2 to 2, so -2 to 2. Okay, so we have here step 2. Step 2 is we're gonna copy once again the function, and then we evaluate. We forgot something. What? We forgot the box. So we make first the box, which is x and mx, which is -2, 1/2, and 2. 1/2 is from this one over here, and then okay, so that's our box there. And then we evaluate. So first we copy once again the function, so it will be nearer minus x. Okay, and then what we're gonna do is we're gonna evaluate it. -2 2 square minus 2. Oh, it is negative. Alright, then -2 is 4. 2 square is 4 minus negative, it is positive, equals to 6. Okay, and then what we gonna do here is also this 1/2 m 1/2 is equals to 1/2 square minus 1/2 is equals to 1/4 minus 1/2, which is equals to 4. 1 minus 4 divided by 2 is 2 times 1, it is 2, which is equal to -1/4. Okay, and then what we have here is 2, so we're gonna put it here, 2, which is equals to 2 square minus 2, which is 4 minus 2, which is 2. So we have the value of 6, -1/4, and 2. So what we have here is first critical number, which means that the only critical have is x equal 1/2. Then we compare the function with -2, 6, 2, and -1/4 from the concluded tens -2. So is maximized. Okay. Okay, this is what I'm looking for. Not that, but wait, this one, maximize. This word, maximize. So we got the biggest number. So the biggest number is is max is when m of x is equals to 6 and when x is equals to -2. Okay, that supposedly is the answer. So no need to get the this one, right? No need to get this one. Okay, but still we need to find this because maybe. Okay, let's look at the graph of it. Whoa, wait. Where's the graph? Okay, here we're gonna try to graph that one, which is x square minus x. So x square minus x, which is where's the graph? I don't know why sometimes it doesn't graph. X square minus, what's that? X square minus x. X square minus x. Okay, here we have it here. So what? -2 to 2, -2 to 2. So it just shifted So if we have here 2 here, and negative 2 is over right in 6, right? So can we write? Oh no, we cannot write anything there. So that's it. It is bigger than this one, right? It is 2 and 2, and this is negative 2 and 6. So we're gonna use this one because this is the maximum value. Alright, so that's it for... Wait, we're gonna try to explain the examples so it will be much easier for you to answer this one. Okay, here in number 1, find the number in the interval 3 negative 3 0 so that the sum of the number from its square is maximized. So sum of the number we have here is the difference of the number, so the difference is x squared minus x. How about the sum? So x squared plus x, and then you get the critical value, and then boom, you will get this. How about this? Find two numbers whose sum is 36 if the sum of their squares is to be minimum. This is a tricky question, right? Okay, so what I did in this number is x squared plus y squared is equals to 36, and then you get the y, and after getting the y should be the f of x. You get what I mean? So in that case, you're gonna need to do more than what is needed. More than this one. So this is a tricky question. It is not part of the example here like this one, but it can still be solved. Alright, it can still be solved. Okay, number 3 is open the box is made in 16 by 30 cardboard cutting equal 4 core. Okay, just like the example here, it is still just the same. You exactly copy the process of how he made it, or the author made it, and then you will get the answer of this. Still the largest volume. And then here, open the box, cutting out equals 4 corners, bending the sides. How long the sides? Still the same. Okay, still the same question with here, just different numbers. And this poster is to have an area of 180 square inches with 1 inch. This is also a tricky question. This is a tricky question because first you have a given area which is 180, and then you have here 1 inch margins at the bottom, 1 inch. So we know area is length, area is equals to length times width, and we can call it a equals to x and y, and then it's equals to 180. So you have a value of f of x, which is also equals to y. Okay, so you have that already. And then you have y, and then you can have it, the next area, it will be length times width, but with x with how many margins. So you're gonna know what will you be using as x here and y here, because the poster has margins like this, and this is margin of 2, and this is just 1. Here also 1, and also 1. And when 1 has minus 3 and 1 has minus 1, I mean minus 2. So you're gonna decide what should, because this will be interchangeable. It depends on you on what is your y and what is your x. Okay, so that's how to solve this one, and I know you can solve this. I have given you this one. This is the most trickiest part because it is not like this one, because here we have sides, but in that one, in the exercises, is we have a margin, margin like that, and we have here 2, and here is just 1 and just 1 and just 1. So, and it is not solving for a volume, it is only solving for a largest printed area. It is just solving for an area. So this is how you're gonna do it. Okay, so that's it for day 2. Hopefully you can answer this one, week 6, day 2. And thank you for watching.